the slope is 0. This is that point. And since the slope of displacement time curve is nothing but the velocity of the particle, so this is the point where the velocity of particle becomes 0, and after this point the velocity of the particle changes direction. So if you want to interpret this graph, so let's say that at time t is equal to 0 the velocity was v1, and because of deceleration this velocity keeps decreasing until it reaches the value 0, and after that the velocity of the particle changes direction. Now let's have a look at distance time graph. Distance time graph is a graph between distance traveled by the particle and the time. This graph is always monotonically increasing since the distance traveled by the particle cannot decrease with respect to the time. So there are some similarities between displacement time graph and distance time graph. Till the magnitude of displacement is increasing with time, distance time graph also follows displacement time graph. When the magnitude of displacement starts decreasing, the distance time graph still increases, and it is actually the mirror image of displacement time graph along the time axis. Also, the slope of distance time graph will give you the instantaneous speed. Now let's have a look at a typical distance time graph. Now we'll take the same displacement time graph and we'll see how we can get the distance time graph from it. So as we have already seen that the velocity becomes 0 at this point. So since the displacement is increasing with time from point A to point B, point B is the point where velocity becomes 0. So from point A to point B, the distance time graph will resemble the displacement time graph, and from point B onwards it will be the mirror image of displacement time graph along the time axis. So this is our time axis. So from point B onwards the distance time graph will be nothing but the mirror image of displacement time graph. That is something like this. Since the distance traveled by the particle cannot decrease, it will always increase. So this is why the distance time graph is always a monotonically increasing graph. So this is all about our distance time graph. Now let's have a look at velocity time graph. Velocity time graph is the graph between velocity of a particle and the time. The slope of this graph at any given point will give us instantaneous acceleration at that point of time, and the area under the graph in a particular duration gives the total displacement in that particular duration. So now let's see a typical velocity time graph. So from here we can see that at time t is equal to t1 the velocity is v1, and at time t is equal to t2 the velocity is v2. So the total displacement by the particle between time t1 and t2 will be given as the area under the graph between time interval t1 and t2. So this is the total area. So this is nothing but the displacement of the particle. Also, the slope of this graph at any given point will give the value of instantaneous acceleration. So now we can say that if the velocity time graph is uniform, that is a straight line, suppose this is velocity time graph, so here the slope is constant, which means that acceleration is also constant. Here since the graph is not a straight line, it means that the acceleration is varying with time. Similarly, we can have acceleration time graph also. This is a graph plotted between acceleration